So chapter 8, we're talking about factoring polynomials. Essentially what we're doing is this. I wouldn't write this in your notes, but when you have like 2 times 5 equals 10, 2 and 5 are the factors. And I'm probably going to erase all this in just a second, but maybe it'd be helpful. I don't know. 2 and 5 are the factors. So when you take 2 things and multiply them together, you multiply 2 factors together to get a product. So the 10 then would be the product. The last part of chapter 7, we were doing that. We were taking 2 polynomials, or a monomial and a polynomial, or it's 2 things, multiplying them together to find the 10, to find the product. What we're doing in this chapter is we're trying to do that multiplication stuff backwards. So we're taking something like this and saying, well, you could write that as what number times what number, or what monomial times what monomial, or what binomial times what binomial. And there's a bunch of reasons for doing that. The one that you may think is the main reason is to torture America's youth. But no, if you're working inside like a bigger problem, you can go and then simplify things when you've pulled stuff out. Or sometimes when you pull out those factors that's significant. And we'll get some of that stuff as we move on into chapter 9 as well. Did you kind of get an idea where we're going? So how can you take something and kind of reverse multiply, so to speak, to pull stuff out of it? So factors, I'm going to write down are numbers that a number can be evenly divided by. And technically the word for that, what I mean by evenly divided by is you can divide it by it and not get a decimal answer. Technically the word is divisible. For example, 6 is divisible by 2, because if you divide by 2 you get 3. But 7 is not divisible by 2, because 7 divided by 2 gives you 3.5. Does that make sense?
Yeah.
So, in other words, then factors for 6 would include 2 and 3 and 1 and 6. Okay, so 6. Oh, actually, that's my next example. So what could we divide 6 by? We could divide it by 1, agreed? And if you divide 6 by 1, you get 6. So you guys remember doing this rainbow method thing last year? So, and you could divide it by 2, and then you get 3. So 1 times 6, 2 times 3. They called it the rainbow because you can kind of connect them that way. Then 28. Could divide 28 by 1, and that would give us 28. So 1 and 28 are both factors. You divide 28 by 28, you get 1. 2 and 14. Anybody remember the trick for 3?
Add them together.
Yeah, if you add them together. So you add them together, you get 10. Can you divide 10 by 3? Nope. 28 divided by 4?
8.
Nice. Yep, 7. 28 divided by 5? Nope. 28 divided by 6? Nope. Because it's divisible by 6 if it's divisible by 2 and 3. It's divisible by 4 if the last 2 are just divisible by 4. Okay, so we did 5. 6 won't work, so we're done. So 1, 2, 4, 7, 14, 28. You guys okay on those?
Yeah.
Awesome. Moving on to prime numbers, if there's no questions. Prime numbers are numbers greater than 1 that are only divisible by 1 and itself. So 2. 2 is only divisible by 1 and 2. 3 is only divisible by 1 and 3. 4? Nope, 4 wouldn't be. 5? Yep, 5 would be. So 5. 6? Nope. 7? Here in 7. So 8. Now, do you agree no more evens could ever be prime? Because all evens are divisible by themselves and 2 now. So we can skip the evens. 9, yes, no? Nope, should divide by 3. 10? Nope, it's even. 11? 13?
Yeah.
How about 15?
No.
Nope. So I just do dot, dot, dot. You guys are good?
Yep.
You could list more if you wanted to. Do it for a while if you're bored. Prime factorization. This was the factor tree thing. Sound familiar?
Yeah.
So what we want to do is we want to take the number 252 and break it up into all prime numbers, so numbers that would be on that list we just did. And if you multiply just those prime numbers, you get the 252. So Prime factorization equals. Breaks the number up into prime numbers. You'd have to multiply to get the number. And really the reason they're throwing this in here is we could use that then to figure out what's the greatest common factor. What's the biggest number a couple things could be multiplied or divided by, divisible by. 252. If it's even, I often will just do 2 and something else unless something jumps out at me. So half of 100, or half of 200 is 100. Half of 52 is 26. So I'm going to divide that by 2. Half of 120 is 60. Half of 6 is 3, so 2 and 63. 63 we could break up into 9 and 7. And 9 we could break up into 3 and 3. A lot of people will go through and kind of circle those endpoints, circle those prime numbers they had. But the proper way to write the final answer is going to be, we have 2 of the 2s. So we could write 2 squared times 3 squared, because there's 2 3s, and times 7. Good. And write it smallest to largest. It'll just make life easier down the road. So 2 to whatever power times 3 to whatever power times 7 to whatever power. 60. Same thing. Oh, I heard a 6 and a 10 from somebody, so I'll back up and do that. So 6 and 10. You could do 2 and 30, totally fine. Just you'll get the same answer as me. 6, I'm going to break it up into 2 and 3. And 10 is going to be 5 and 2, or 2 and 5. So 2 squared times 5. How are we doing? Okay on those? Awesome. The next page. If we're doing the greatest common factor, abbreviation would be? GCF. Yes, GCF. GCF, greatest common factor. So this is going to be factors, we said, were numbers you multiply together to get a product. So factors are is that product then divisible by? So the largest number that 2 numbers are divisible by. So are divisible by. And that definition of divisible, again, is you could divide by that and not get a decimal answer. So to find the greatest common factor of numbers, first thing you could do is list all the factors. So if you would flip back to the last page of your notes, that's what we did in that very top part with 6 and like 28. We just listed all the factors, that rainbow method. You could do that. That works if the numbers are small. If you have a big number, you might want to do prime factorization. And if you're looking at that and you have no idea what we're talking about, you could just quick right underneath that factor tree. You're going to look back at your notes. And then what you do is you multiply the common factors. So multiply common factors. So in other words, we just did a factor tree on the last page for 252 and 60, and we came up with these for answers. So as we're looking at these numbers, so that and this, they both have 2 to the second power, agreed? So they both have a 2 times 2. So 2 squared, or 2 times 2, are going to be common factors. This one here on the left has 3 times 3, or 3 squared. This only has a 3. So we multiply then by 3 or 3 squared? 3. Just what's in common. They both have at least 1 3. They both have 1 3 in common. Then we have a 7, but this doesn't have a 7. We have a 5, but that doesn't have a 5. So these are the only ones in common. So 2 squared times 3 is 12. 4 times 3 is 12. So in other words, for 252 and 60, the greatest common factor, or the largest number you could divide both of them by and not get a decimal, is 12. We okay on those? Mm-hmm. Cool. Then, anything at all? Cool. So that's what that should be all the review stuff. Now we're just going to take it one little step further, and the step isn't bad, so don't stress out about it at all. You'll be good. Greatest common factor of monomials. So monomials are going to be things like this, or that. Basically, you have one clump. You never have an addition or subtraction, because addition and subtraction would separate 2 terms from each other, and suddenly it's a binomial or some kind of polynomial. Good? All right. Then this here, First thing is, like with the 8 or with the 6, you just do factors just like we were doing up above, either rainbow method or the factor tree things. And then you also can pull out all the variables they both have. I think is what I wanted to write, or flip my notes over. Or all the variables they have in common, whichever one makes more sense to you. All the variables they have in common. Or all the variables they both have. So 8 and 6. I'm guessing you can probably just look at that and say greatest common factor has to be just the 8 and 6. 2. Should I go through kind of the, I guess when in doubt, 1 and 8, 2 and 4, and that's it for my 8. For my 6, I'm going to have 1 and 6 and 2 and 3. So if I look at those, 2 is the biggest number that are both factors of both. Good? Or I could have done like the factor trees and would have seen they both have a 2. Factor tree for this is 2 to the 3rd. Factor tree for this is 2 times 3. So it's just a 2. Good? All right, I won't pain you with all that again. Okay, so we can pull out a 2. And how many x's are in both? 2. I'm asking it kind of in a little bit of a bad way, but this is x times x times x times x. So 8 and then 4 x's. This is 6 times x times x times y. Do you agree they both have 2 x's?
Yep.
So we can pull out an x squared. Technically, my language isn't quite right because it's x squared, not 2x, but they both have an x times an x. So that's the greatest common factor of those two, 2x squared. Questions? Let's do the next one like a lot faster. Okay, this here, the number we could pull out of 20 and 5 would be 5. So 20 is divisible by 5, and 5 is divisible by 5. It's the biggest factor for each. And then we could pull out x to what power? Squared. Yep. Because this one here has x times x. This has 5 x's multiplied, so an x squared is the biggest. In application then, if you have 16 guys and 12 girls in a class, what's the largest possible group size with groups being all guys and all girls? Does anybody know what we're trying to really do for 16 and 12? Trying to find the greatest common factor. What number could you divide both the groups by? How many people could you break the groups up into? Groups of, and not have a decimal, not have a partial. And it's 4. Yep. So 4. If you weren't sure about that one, you could take the 16 and say 2 and 8, 2 and 4, 2 and 2. So then 16 is 2 to the 4th. 12 would be 3 and 4, 2 and 2. So 2 squared times 3. So you could multiply what they have in common. They both have a 2 squared or a 4. Work for you?
Yeah.
And so then the question is, how many groups would there be total? You could do this a couple ways. Anybody see the answer? 7. Did you do the 16 first and then the 12? Or do you combine them all together? Okay. So one way to do it is say, okay, if there's 16 guys plus 12 girls, there is 28 people total. Agreed? Then if you're going to have groups of 4, divide that by 4 and you get 7. For me, in my head, I looked at it this way. If I'm doing 16 dividing by 4, that gives me 4 groups. If I'm doing 12 divided by 4, there's 3 groups then of the girls. So 4 groups of guys plus 7 groups of girls. I'm sorry, plus 3 groups of girls is 7 groups total. So. Any questions?